Okay, so today, I did it. Today we're learning the fundamental theorem of calculus, which is also called the first fundamental theorem of calculus. And the reason that some people call it the first fundamental theorem of calculus is because later on we're going to learn the second fundamental theorem of calculus, right? Okay, so you can call it the FTC or the FFTC, whatever floats your boat. Alright, so here is what the fundamental theorem of calculus is all about. It's technically, basically, the definition of what we call a definite integral. And what it says is, when you have an integral from a to b of f of x dx, this equals big F of b minus big F of a. What is big F of x? Big F of x is the antiderivative of little f of x. So in a nutshell, what this says is, when you want the integral between 2 points, and we'll talk about that in a second, you find the antiderivative, plug in the top number, and then plug in the bottom number and subtract. Now, what does that mean? In derivative world, when we wanted a specific derivative, like f prime of 5, there's just one number to plug in, 5. I want the slope at 5. Instantaneous rate of change, one spot, right? But for integrals, integrals give you area. And there is no such thing as area at one spot. You need area in a region, right? So for area, we have to have a left bound and a right bound. Or a lower, you could think of it as a lower bound and an upper bound. So this a and b, this is your lower limit. These are called the limits of the integral. This is your lower limit, this is your upper limit. These are the exact same a and b that we were using when we did exact area the long way. Right, so all of that b minus a over n for width stuff, that's the a and that's the b. It's the x values in where you want the area in between those two x values. Does that make sense? Okay. Alright, so what this gives you actually is a number. The answer to a definite integral is a number, and it relates to the area between this curve and the x-axis from x equals a to x equals b. It is not exactly equivalent to the area. Sometimes it is, and sometimes it's not. And that's what we're going to explore today, right? So this big F notation, you know how we have cutesy notation for derivatives, right? If I have f of x, the derivative is f prime of x. Easy, cute, done. There's no cutesy notation for integrals, for an antiderivative. So if I have f of x and I want to write the antiderivative, there's no f anti-prime notation. So instead, traditionally, most textbooks and a lot of mathematicians use capital letters when they are talking about the antiderivative of a function. That doesn't mean if you see a capital letter, it's automatically the antiderivative. You still have to specify where big F is the antiderivative of little f. You still have to put that there because you can't just assume capital letters mean antiderivative. But that's traditionally what
Is there a difference between an antiderivative and an integral?
An antiderivative is basically the solution of an indefinite integral. So this right here gives you the antiderivative of f of x, little f of x. Alright, the definite integral uses the antiderivative in order to find the process. So here's how you do it. If you have to find a solution to a definite integral, so say you have this problem, how do you actually process it? I'm just going to show you some notation so you understand what you're going to have to write. So the first thing you're going to do when you're presented with a definite integral is you're going to have to find the antiderivative. So I'm just going to call the antiderivative big F. We're just going to continue with this kind of stuff. So you find the antiderivative. Then you write a vertical bar. In math, vertical bar means evaluate. I've asked this before, but I just want to make sure. Does anyone here own a TI-89 graphing calculator? Not one person in the room?
Nice report.
Okay. All right. Yes, that's what you think of when you think of Milton is poverty. Okay, so, anyway,
Extreme and utter poverty.
alright. But anyway, a TI-89 has this vertical bar button as one of the buttons on the calculator, and if you say I typed in a function like x squared plus 2x minus 4, and I wanted this evaluated at x equals -3, I would hit the vertical bar button and then type x equals -3, and it'll just plug it in and give me the answer, right? So, vertical bar in math means evaluate. So for us, we're going to put a vertical bar, and then we're going to write both the limits. So we write the low one low and the high one high.
That noise is very irritating.
Oh, here. I'm so sorry, I forgot that this is not on mute. Is that better?
Yeah, that's perfect.
There you go.
Jesus Christ.
Oh, you're so welcome. All right, so we have the integral, then we write the antiderivative with a vertical bar and the limits, and then we actually plug them in. So then you do big F of B minus big F of A. All right, so let's walk through an example. We're going to do a couple examples, and then I'm going to show you how this relates to area. By the way, all continuous functions are integrable.
Say that 5 times fast.
Yes. All continuous. Are all continuous functions differentiable?
Yeah, maybe.
Is every continuous function
No.
differentiable?
Yes.
Yes.
That's one of the rules for.
I don't even know.
No, it's
Wait,
not.
what if there's like a short
Continuity, but
term?
not
Wait, what if there's a sharp turn?
Wait, I said no first.
Right?
Yes.
Okay, what if there's a vertical tangent? Right? So not every continuous function is differentiable, but every continuous function is integrable.
This isn't.
And what that really means is every function that's continuous, there has to be a way to calculate the area. There has to be area between that function and the x-axis. All right, so every continuous, and actually a lot of non-continuous or discontinuous functions are also integrable. So you can actually calculate area even for functions that aren't necessarily continuous. There's still area, right? There's always a way to do it. Not every function, though, has an antiderivative. Every function that has a derivative, you can do it backwards, but not every function that you think up has an antiderivative associated with it. But every function that's continuous has a way to calculate the area, and so therefore is considered integrable. So if it's continuous, it's integrable. All right, so here we go. We're going to start with the integral from 1 to 4 of 3x squared plus 4x minus 1 dx. Now the first thing that you should find when you are processing a definite integral, what's the first thing you always find? Yes, the antiderivative. So everyone take a second and find the antiderivative of the function.
So you have to use that one.
What one rule?
It's like 1 over n plus 1 x plus 1.
What?
Yes, the power rule.
Jesus, what are we finding?
Just the antiderivative of this,
So then wait, why is he talking about the power rule?
because that's the rule you use to find the antiderivative.
Oh, I just memorized how to do it.
This the process, yeah, I know. It's okay. All right, so
Your water bottle.
tell me the antiderivative.
X cubed plus 2x squared minus x plus c.
Good. Okay.
Whoa,
For-
where's the C?
Definite integrals, you don't have to write the plus c. And I'm going to show you why in a minute,
That's that.
or heavy. Yes, depending on how you look at it, right? Okay. So for definite, you can, but I will tell you, nobody does, right? So you can, it's mathematically correct to write the plus c, but nobody writes a plus c on a definite integral, so if someone sees you doing it, they're probably gonna like look at you funny.
Make fun of you.
Yeah,
Doesn't
yeah.
it just
Talk
cancel out?
behind your back.
Oh my gosh, you read the constant of
Doesn't
integration.
one
It's
invite
like-
people to-
oh, it's so crazy.
Friend gathering.
Okay, so, anyway, you write your vertical bar and then you write your limits.
I never get invited to friend gatherings.
Make sure for all integrals in this class, you always want your limits to go the lower number to the higher number. Once in a while, a problem will be presented with the higher number on the bottom and the lower number on top, and I'm gonna show you how to flip the limits in a few minutes.
You just write them differently or no? Is that what
There's an actual thing you gotta do.
Swipe or no swipe?
Yeah. Okay. So here we go. So we've got the antiderivative, now we have to evaluate it. So the first number we plug in is always the top number. Bigger number goes first, so you plug in a 4, so you get 4 cubed plus 2 times 4 squared minus 4. Then you subtract and plug in the lower bound, or the lower limit. Make sure you subtract the whole quantity, not just the first term. So if you are not good with your negative distribution, when you have a negative, if you're bad about doing those parentheses, please don't be bad at it. So here we go. Okay, so we've got, and then you just do it. So 4 cubed, you have 64 plus 32 minus 4 minus 1 minus 2 plus 1. And just add them together. So you get 96, 92, 91, 89, 90. That is the value of that integral.
That's the area under the curve of that thing.
Possibly, but not necessarily.
What if I just threw that at the camera?
Okay, possibly, but not necessarily. All right, let me give you guys another one. I'm going to do a simple one to try, and this is going to help lead into this whole area discussion. So I want you guys to take a minute and find the integral from 1 to 4 of 2x dx. And see if you can do it start to finish with proper notation. All right. Okay, so what's your antiderivative?
X squared.
X squared from 1 to 4, so you get 16 minus 1, or 15. Everyone get 15? Okay.
Is that how all the tests will be?
Yes, that's exactly it. Really, this is the only function we ever use this semester, and we just change the numbers. Right? Okay, so as a matter of fact, let's change the numbers right now, just for fun, okay? So we're going to go -2 to 1 of the same function. Take a second and find the integral from -2 to 1 of the same function.
It took you a long time to stop it.
Yeah.
Alright, so you get x squared from -2 to 1, so you get 1 minus 4, -3. Can you have a negative area? No, you can't. Area cannot be negative. So, does that mean the area of this region is 3?
Yes.
Okay, good, take a stand, right? Yeah, no, it's not 3. It's not 3, it's not -3. It's related to -3, but -3 is not the number. It's not.
Is it 9?
It's not 3, it's not 9.
That's embarrassing later.
Alright, so let's talk about this. I'm going to very quickly sketch the graph of y equals 2x, because this is the function we're talking about. It's the area under this curve. Not this. This is our area finding function. This is what we're talking about for area, right? So if I go from -2 to 1, so that's -2, here's 1. So this total area is what I'm talking about, right? This is a triangle, so I can find the area geometrically. So this is y equals 2x, so this would be -2, this would be -4. So 1/2 times 2 times 4, so we get an area in here of 4. Here, this is 1, this would be 2, 1/2 times 1 times 2 is 1. So the area over here is 4, and the area of this little triangle is 1.
So you add them together.
Well, then we'd get 5.
Is that right?
Under the x-axis is negative.
Ah, did you guys hear that?
No.
That was inductive reasoning, a very excellent use of inductive reasoning. All right, so here's what she said. This triangle happens to be below the x-axis, and this triangle happens to be above the x-axis. If we made the conjecture that when the region is below the x-axis, the value of the integral will be negative, and we took a -4 plus 1, we get the value of the integral. What happens when you have a graph is any portion of the graph that's below the x-axis ends up yielding a negative integral, and any portion that's above the x-axis ends up yielding a positive integral. So when you have a graph where part is below and part is above, the total of them are just meaningless because you have no idea what the actual area is. It's just this number. So if I wanted to actually find the area of the region using integrals, the only way to do it is to figure out where it changes and do the area from -2 to 0, do that integral, make it positive, and add it to the integral from 0 to 1. So you'd have to take all your negative parts and do those integrals separately, and then do all the parts that are above the x-axis, those integrals separate.
Can you give us an example?
Besides this one?
Yeah.
Yeah, there's no
Ah,
sign.
yes.
Not a linear line.
Yes.
What if
Oh, you want one that's not a line?
What if it's like, what if it's
Okay.
x to the
Okay.
3? Can you do x cubed?
I see you
Let's do
probably
an x
want
cubed.
to
Let's just
some-
try to make it as
So-
hard as possible.
Okay, you want to do a simple x cubed.
Yeah.
Now let's do something fun.
We have
Alright.
to
So
drive this one.
let's say x cubed has origin symmetry, right?
Yeah.
So if I were to do the integral from -2 to 2 of x cubed dx, I want everyone to just find that integral, -2 to 2. See if you can think about the way the graph looks, and see if you can think about what that integral is going to end up being. Alright, so our function is 1/4 x to the 4th from -2 to 2. So 2 to the 4th is 16, so we get 4 minus 4. We have an integral of 0. Is that saying that x cubed has no area from -2 to 2?
No.
No.
Well, then why would the integral be 0?
See,
Because
Very
It's the same.
Because it's symmetric, so the area here and the area here are the same, but that one's going to be negative and that's going to be positive, and they wipe each other out. So if I want to actually find the total area, I would have to do the integral from -2 to 0 plus the integral from 0 to 2. Or, since it's truly symmetric, is there a faster thing I can do?
Multiply by 2.
Just do the integral from 0 to 2 and double it, right? Alright, for time's sake, we have 2 times 1/4 x to the 4th, 0 to 2. So I get, this is 16, 4, 8 minus 0. The total area from -2 to 2 would be 8.
So then we can't just like add the two numbers, or no? Is that
You
not-
could, if you found this, you'd get a negative, so you'd have to take the absolute value, make it positive, and then add them together.
So could we technically like for that one too, just take the absolute value of the negative number?
No, because remember, if you've got part below and part above, you can't just take you have to split it so that you only do the integral of the stuff below, and you only do the integral of the stuff above.
No, but like
So
not the
then-
absolute value
then
of
you just take, then
but
you
the
take.
absolute value of like f of a and the absolute value of f of b, and then we no, that wouldn't work either. All right.
You gotta split up the integral. There's no way around it. Okay.
Is this proper notation or is this going to the right answer?
Is it proper notation?
You can't do that because of proper notation, or
Can't do what? Take the absolute value of a function before you start?
Cure
Yeah.
It won't give you the right answer. Oh, yes it would. You're talking about take the absolute value of the actual function and then do the
Yeah, of
integral?
like-
Yeah, do you know how to find antiderivative of an absolute value function? Do you really want to split them all, every function up into a piecewise?
No.
Same thing.
No.
I was talking about the big F, big F one. So that's wrong.
You can't do the absolute value after you're done. You'd have to do it at the beginning. You could take the absolute value of your functions before you start because that would flip everything positive. And when we use calculators, we will do that. But right now we're not going to.
You excited for hibachi?
Yeah, when they do like the choo-choo train thing with the onions, that's my favorite one.
Right. The volcano.
What?
Did you bump right there?
No, the volcano. The fire scares me. It's really big.
Alright,
I like the yum yum sauce. I get 2 yum yum sauces instead of like a yum yum and that other one that's disgusting. And then I ask him to pour the yum yum sauce over my rice, and then I don't eat anything till they're all done. And I separate all my food, and then I eat all the rice and I eat all my vegetables, and then I have like the 2 meats or like whatever battled out to find the best one.
we have some properties of integrals.
It's a whole long process.
What are you doing after school today?
So if I need the integral from A to A, whoa, that'd be like the integral from 5 to 5.
It doesn't exist, does it?
Well, it exists, it's not non-existent, but what would the answer be? Zero. Technically, a line, by mathematical definition, has no width, right? And if you think about it analytically, if we found the antiderivative, plugged in the top number, and then subtracted plugging in the bottom number, and they were the same, we'd get 0.
So it'd be like that,
Right.
except they would be both be positive, right?
So yeah, it'd be 0. So the integral from anything when the limits are the same is always 0. All right, property number 2. Suppose your limits are given high to low. Okay, suppose they gave you, instead of going left to right, they went right to left. We used to, I will probably do this again this year. I used to say, oh no, they're high to low. So when your limits go high to low, you have to switch them. Mathematically you don't, but conceptually you're going to get problems wrong if you don't. So you're better off to just always have your limits go low to high. And the way that you do that is you just multiply the integral by -1. And then you can switch the limits.
So wait, when would you do that? Like at the very beginning?
Yes, yes.
So then you would just.
First thing, you don't even start evaluating the integral if the limits don't go low to high.
So then when you multiply it, would you just be multiplying the function by negative?
Yeah, or the answer. You can hold the negative to the end.
So okay, so we could like multiply the antiderivatives. Is that okay?
Whatever you prefer.
Whatever
And
floats your
actually, yeah, whatever floats your boat. More often than not, what you'll find for these kinds of function is the function itself will have a leading coefficient that's negative, and you're going to want to go ahead and multiply the negative in. All right. Third property, the integral from A to C is equal to the integral from A to B plus the integral from B to C.
It's kind of like a no-brainer, isn't it?
If B is between A and C. So if I need to find the integral from 0 to 10, I can do the integral from 0 to 3 plus the integral from 3 to 10. And that's the same thing as the integral from 0 to 10. So I could split it up 5 ways if I wanted to, as long as I'm just going in order. right?
You could split it up in millions.
I could. I don't think I would want to, but you
Wherever
could.
your thumb is stopping. Sorry.
All right. Very quickly, just so that you've got it on paper and you understand the difference, we're just going to write one quick thing down and then erase it, because I've already spoken about this, but this is just so it's in your notes. So, we have two types of integrals. We have an indefinite integral, and we have a definite integral. An indefinite integral would be like the integral of 2x dx equals x squared plus c. So an indefinite integral is basically just the antiderivative. The answer is a function, and it's a function that helps you find the area under this curve. It's like an area finding function. A definite integral is the integral from a, let's actually do one like 1 to 2 of 2x dx. This one the answer is a number, and that number relates to the area between the curve and the x-axis in between these two limits. Sometimes it's equal to the area, sometimes it's not. It just depends on if the entire region is above the x-axis or not. Okay, so we're going to do a few examples. We're going to use these properties in order to figure out the values of some integrals. And I've decided I'm going to mix up the problem and make it a little bit trickier than what I did first period, just because I can. Okay, so suppose the integral from 0 to 3 of f of x dx equals 4, and the integral from 6 to 3 of f of x dx equals 1. Find the following. A.
What's your seat? What seat are you sitting in? I
And
brought mine.
C. Okay, so we're given that the integral from 0 to 3, yeah, that's good. The integral from 0 to 3 is 4. The integral from 6 to 3 is 1. And you're going to use that information to find these three values. Go ahead and take a minute in your groups, see if you can figure them out.
Alright, I got it. You get 0, negative 1, and 5. Use the property
See,
for
like, you just add, yeah, you just add one
other stuff. Then you've done it.
I'm so hungry right now.
Oh, I forgot my lunchbox.
Yeah, but I think it would still be the same value.
No.
Actually, no.
What's where are your tissues? Somebody steal them or break?
Stop.
It's probably to stop them.
Probably not doing stuff. That kid's always doing something.
Who steals tissues?
Mustafa does.
We had that on camera. Everything you say right now is on camera.
Alright, do you guys need another
Right to
minute?
remain silent. Anything you say.
Hey, what's the integral from 3 to 3?
0.
0. Don't even need to know any information, you know if it's 3 to 3, it's
We
gonna
gotta
be
use the
0.
properties.
Alright,
-1.
hey, so the integral from 3 to 6, but it says here it's 1.
But you multiply by a negative.
Yeah, we gotta multiply.
This is the integral from 6 to 3, right? So the integral from 3 to 6 would be the negative of this integral, which means it would equal -1. Does everyone understand that?
Yes,
Okay. Alright, so now to find the integral from 0 to 6,
5.
well, we'd have to do the integral from 0 to 3 plus the integral from 3 to 6.
Are you good at winking, Miss Price?
that's
Did you just try to wink?
Wait,
'Cause
why
I didn't
would
see
you-
it.
No.
Oh, it's
Why
wrong.
would you take the integral from 3 to 6?
Oh,
not the
snap.
integral from-
You're so smart. See, I see what you did there. 4.
I
You gotta use
understand
the.
it, but
No, we
like,
did 6 to 3, not 3 to 6.
I don't understand why you cancel out your areas. Like why? Like it seems like with C, you just cancel out
Let
the
it be
area
Ryan. Let it be
from
Ryan.
3 to 6.
What is that?
With the area.
No, that's wrong. Wait, that's wrong.
Isn't it 5?
Yeah, why are you messing with me?
Wrong.
You made me correct my work when my work was wrong.
Yeah, it should be 5. Because you just like you
No, the integral from 0 to 6 is the integral from 0 to 3
Then Jacob's wrong. Jacob.
Plus 3 to 6.
plus the integral from 3 to 6.
Jacob
Yeah,
give
but
me.
like,
Oh.
even if it wasn't a negative number, why would you want to cancel out your areas?
Because that's
Yeah,
the
Jacob.
numerical value of the integral.
Jacob, why are you lying to me?
That's so noobish. That can't
That's not
be.
That's not wrong.
Noobish.
That's right, Miss Jacob.
Okay,
I don't like this.
Jacob's in denial right now.
we
Jacob
have
thinks
to
he's
learn to
right.
like it. Okay, I have one more, we actually have 3 more
It's
examples,
right.
and I don't know why we're actually packing up. We've got almost 10, 15 minutes left.
Yeah, but
So-
we wanna know if you
Yeah,
can wink.
yeah.
We wanna know if you can
So-
wink, Miss Price.
I thought we'd get out.
You wanna know if I can what?
Yeah, wink. Can you wink? That was horrible. I'll be honest, that was probably the worst wink I've ever seen in my life.
Alright, this is related to the same example, it's just letter D, okay?
Wink.
So same setup, same example, letter D,
No, Mustafa, why didn't you come to
and I'm gonna tell you right now,
use that shit paper?
don't feel bad when you try this one if you get it wrong, because not one student in first period got it correct on the first try.
Challenge
So,
accepted.
give it a shot in your groups, see if you can figure out the answer to this one.
Alright, so it's proper order 6 over B. Alright, so that's good. So we know I need that stuff. Alright.
So many properties.
Alright, so it's integral. Alright, so that's gonna be 5x.
Wait, you have to give me a second.
I'm gonna give you a second.
I just did this.
I just gotta make sure that it's on camera.
But what you might have to do is do each one. So what's next? Am I right?
Yeah, I didn't think so.
Wait, what
Here.
did you get?
Why don't you set off next?
You have to do like -5 f of 3, -5 f of 6. Subtract.
But how do we know what this value is?
So you have to plug it in. So you have
Well, where's the?
you have to.
No, now you're not on track anymore.
David screwed me up twice. Like I got.
You were on a very good thought process.
What was the thought process?
He said the word split it up.
Don't you keep your notes right here?
Yeah,
Said you were good until you said split it up. So
No, she said we were.
it doesn't say how to do it.
This is a source of big mistake for students because they will want to take -5 of -1 and 3 to get 8. This is not the answer.
Price has a prompt.
These are my notes to my long-term
They need to
sub.
understand that the integral of 3 is not 3. They need to split up the integrals as below. Ooh, it's 14. Yeah. Boom.
Miss Price
Why
has a
do you
prompt.
do this? Why?
If she
I was
All right.
watching like
Obama.
that.
Were you ready
Okay,
for this?
I'm gonna show you visually why. This will help you have a comfort level with this, okay? Alright, first of all, the answer to this is not 8. It's 14.
As I so cleverly derived.
Yes, yes. So here we go. You have to split up the integral, and the reason is because when you're adding a constant to a function, if you were to take the antiderivative of 3 is not just 3.
It's 3x.
It's 3x, right? So when you add a constant to a function, you can't just add that constant to the answer. It doesn't work like that. So instead what you need to think of for this is you need to think of it as the integral of from 3 to 6 of negative 5 f of x.
Can't you bring the negative 5 up?
You can, absolutely.
And
Plus the integral from 3 to 6 of 3.
Oh.
Now, the integral of negative 5 f of x dx, Rayon's absolutely right. You can put the negative 5 in front, it's a scalar. So you have negative 5 times the integral from 3 to 6.
Hi, pardon the interruption. Could I have Noah Nutter to the field house, please?
Sure.
Thank you.
You want
So you get negative 5 times negative 1. Negative 5 times the integral from 3 to 6 of f of x, which is negative 1. So you get negative 5 times negative 1 plus the integral of 3. Well, the integral of 3 is 3x from 3 to 6. So what we get is 5 plus 18 minus 9, or 14. I want you to keep in mind, when you add a constant to a function, you've got to split that function up and evaluate the constants separately. I plugged in the 6, and then plugged in the 3 and subtracted. All right, I'm going to show you visually why. Thank you so much. With a quick 2-second graph. So, okay, suppose this is f of x. Here's 3, here's 6. All right, so say we've got some area, right? And let's just, for argument's sake, say that this area is 5. If we were to take f of x and shift it up 3 spaces, because that's what this, when you add 3 to a function, that's what it does, right? It's a vertical shift up 3.
True.
Right? To the area, this is still our area of 5. To the area here, you're not adding 3, you're adding a 3 by 3 square or rectangle, right? So whenever you add 3 to the height of the function, you're not just adding 3 to the area, you're adding 3 times this width here. So you end up, in this problem, adding 9 to the area, because it's a 3 by 3 rectangle. So anyway, that's just visually why that works. Just keep in mind, when you add a constant to a function in integral world, you've got to actually separate it and really evaluate that integral, and that is going to come up a lot. The College Board loves to throw that at you just to see if you're on your toes. Okay, we have a couple more quick examples. One's really fun.
Is it going to be E?
Is it going to be what? E? No. We're done with that one. Are you happy to be done with that
I
one?
didn't know it was still part of the original things, that's why I got it wrong.
Oh, I'm sorry.
I was like, how do you know f of x?
Uh-huh.
You gotta specify next time.
Okay.
Specify maybe a little harder. Ooh, graph. It's my favorite form of graphing.
Graphing is your favorite form of graphing?
Yep.
Good.
As
All right.
opposed to like skin graphs where you like rip skin off and then put it on other parts. Yeah, graphing is my
That's
favorite.
not as much fun.
Yes.
Okay. Okay, so here we go. We've got a graph. This is a graph of f of x. I'm going to write a few numbers in here. I'm going to write 10, 2, and 3. And I'm going to go ahead and shade that part, and that part. Suppose the numbers represent the area of each bounded region. Okay? If I asked you the total shaded area, what would it be?
I want to say 15, but it's probably going to be like 11.
No, it's 15.
No,
Remember,
it's 15.
We had to like switch
That's
it
the
on
area.
this one.
15, right? Area is positive. Area is area. Area is positive. It's 15. Can't have negative area. But suppose I called that A and that B, and I said, what is the integral from A to B? Now what would it be?
11.
It'd be 11.
Darn it.
Because anything
That's awful.
above the x-axis is positive, below the x-axis is negative.
That's right on, by the way. You haven't heard his voice much this year, but he's a quite in-depth member of the team.
Now,
That's like not.
what I want you guys to make a tiny little association with that will maybe make you happier
Okay.
is when we get into an application, say, PVA. Ooh,
Good class.
this reminds me a lot of distance versus displacement, doesn't it?
No.
Right?
Yeah.
Right?
No.
Oh my goodness, because gosh, isn't it true that when we move to the right, velocity is positive and the left, velocity is
You know
negative?
what I should have done this
So,
class?
oh,
Throughout this year, I should have narrated all your videos, and then like during right now, I'd be like, this is the part where all the students start taking this class.
alright, we have one more concept.
One more.
I don't think we have enough time.
We do, we've got like 5 minutes.
No, we don't.
We do. We have 5 minutes.
Concept limit for class.
Okay, this concept is a key one, so don't pack up. Here we go. Shh. Last example and then you're free.
Debatable.
The day of my living.
Okay, suppose the integral from 3 to 8 of f prime of x equals 10 and f of 8 equals 6. Find f of 3. The fundamental theorem of calculus can be used to find the value of an antiderivative at one specific point. So I have f prime, and I want to find, oh gosh, I forgot to write. I am so sorry. Oh,
You should be.
I'm so sorry. dx. There we go, fixing it right now. Okay. So I have f prime, I've got this integral of f prime. I know f of 8. How can I find f of 3? This is where the fundamental theorem of calculus can actually be thought of as almost like an equation solver. So I'm going to write it out. We're going to write out what we're given. The integral from 3 to 8 of f prime of x dx. But I'm not going to actually write equals 10. I'm going to say, hey, this antiderivative would be, I'm going to just call it big F, right? I don't know what it is, but we'll just call it big F of x. Evaluated from 3 to 8. Oh, I'm sorry. God, see, this is why I need to shut off the camera. This is F.
Okay. There we go.
Oh, so sorry. See, the non-dx thing just completely fried my brain. Okay. So yeah, I'm sorry. This is f prime. The antiderivative would just be f. Okay, so we have f prime, the integral of f prime 3 to 8 equals f of x from 3 to 8, which would be f of 8 minus f of 3.
You could equate this to 10.
Yes. So now we know, hey, that's 10, f of 8 is 6, f of 3 is what we want,
That's minus 4.
so f of 3 is negative 4.
Called it.
You said positive 4. That means you got it wrong.
Okay, I'm so sorry, I hope I didn't confuse you. I'm so sorry for those of you watching on the tape, I hope I didn't confuse you.
Alright, now we're free.
Okay, so anyway, just think of it, when you need an antiderivative at one point, you set up a definite integral and go ahead and evaluate it and see what happens. And usually you'll have enough information to solve for that missing point. Okay? All right, you're free. You are free.